Hey, morning, guys. It's Mr. Letty. Just wanted to give you guys a quick lesson on weathering. I'm going to be recording a series of these, showing the notes. They should each take about 10 to 15 minutes. And by all means, pause the video whenever you need to make sure you can copy the notes. So you should have your notebook or your Chromebook out with you so you could be copying these down. And if you have any questions, you can always reach out in Remind or in Classroom if you need me to clarify anything in the notes. All right, so that being said, let's just get right into it. This is our new unit, Weathering, Erosion, and Deposition. Okay, so first of all, I'm going to have to spend some time going over stuff that in middle school you guys learned and in all likelihood learned incorrectly. Okay, so when I say erosion, you guys tend to think that that's the breaking down of stuff. It is not. All right, so the first thing we're going to cover is weathering, is the actual breakdown of rock. Okay, all erosion is the movement of the sediments. So after it weathers, erosion comes in and takes it away. All right, so that's going to be things like wind and water, something that's going to carry it. And then finally, we have deposition. Excuse me. So it's going to be the dropping of sediments. So big and round objects take the least amount of time to settle, so they go the fastest. All right, and then your flat objects will take a long time to settle. Okay. All right, and as you can see here, just a quick little diagram showing you the process. We start off up top here with the freezing. Okay, so we have wind, rain, something that's going to break up the rock. That rock is then usually carried away by, let's say, a river. That's your erosion. Okay, and we get all the way out to the end to deposition, which is going to be a delta or something like that. Okay, so let's get into the types of weathering. Today, we're only going to cover mechanical weathering. Tomorrow's lesson will be on chemical weathering. Okay, so again, simply the breakdown of rock into sediments. All right, it occurs at the Earth's surface. Obviously, it's hard to break down stuff when it's buried deep underground. Okay, and this is going to be because it's things like air and water, um, living things, acid rain, stuff like that, that's going to break down the actual material. Okay, so for our physical weathering, here's the stuff you need to know about. Number one, the way I like to think about it is like chewing food. Okay, so for physical weathering, which is also called mechanical weathering, uh, you're not changing what the thing is, you're just making it smaller. Okay, so if you have a chocolate chip cookie and you take a bite of it, you just have smaller pieces of chocolate chip cookie. All right, we haven't changed what it actually is yet. All right, and there are four main types of weathering that we're going to worry about for physical or mechanical weathering. Okay, abrasion, which you may have heard that term, that's going to be basically scraping. Okay, so think of a rock bouncing along the bottom of a riverbed or at the beach as the waves come in and it pushes the sand up and then it pushes back down, that sand is scraping against a rock. All right, frost action, which we'll spend some time getting into. Okay, exfoliation, which is exactly what it sounds like for those of you who, go to a spa, where when your skin is exfoliated, they're taking off the outer layer or the dead layer of skin. The exfoliation of rocks is they're removing the outer layer of the rock. Okay, and then finally we have plant and animal action. Okay. So frost wedging, if we look at the diagram on the side here, if I start off with a crack in a rock, okay, and then during the day we have some sort of melting or rain, water is going to fill up that crack. Okay, and then at night the temperature drops. So what happens to the water? The water is going to freeze. And we remember that when water freezes, water expands. Okay, so what's going to happen is it's slowly going to push against the rock. And then the next day the sun comes out, the water melts, or I'm sorry, the ice melts, turns back into water, all right, fills back in to the very bottom where we've expanded the crack a little bit. Okay, and the process keeps repeating itself. So slowly, the rock is being pushed apart until eventually it can't take anymore. And then you have pieces of the rock falling off, and we're going to call that talus. Okay, so you can see in the picture on the right here, this huge crack. Okay, and then during the day, again, water is going to seep down into that crack where it will ultimately freeze and keep pushing that apart. Okay, you may also hear something called frost heaving, very similar, but instead of pushing stuff apart, it's pushing stuff up. Okay, so you'll see that with patios, things in your backyard, similar to what you see with sidewalks, except instead of frost doing that, that's usually tree roots. Okay, but it's lifting the pieces of the sidewalk up. All right, which is going to cause the concrete to break and things like that. So you should be familiar with that. Okay, number 2 are plant roots. So if we look here, similar to frost action, okay, plant root, it has water in the crack of a rock. So what are the roots looking to do? The roots are looking to bring water up. So the roots will grow into the crack of the rock. Okay, once it's in the crack of the rock, it's going to start to drink the water, okay, and bring it up into the tree, plant, whatever it happens to be. All right, and what's going to happen to that root? Well, as the plant or tree grows, the root is going to get thicker, but it happens so slowly. Instead of just pushing itself out of the crack, it grows at a very slow rate, so it pushes against the rock. Similar to the ice in a frost wedging, this is going to slowly put pressure on the rock, which ultimately will allow it to crack. Which, if we can continue, as it starts to crack and continues to crack, ultimately that tree or plant is no longer going to have a spot to survive, because as the rock breaks away, that's where its base is, and then that plant will probably die. Okay, and here you can see a picture of exfoliation. So I have this very large rock, and you can see the cracks here in the bottom left hand corner, okay, and down towards the bottom center and bottom right. Okay, and that's where all of the outer layer is peeling off. So for those of you who have never been to a spa and don't know what I'm talking about when I say exfoliation is removing the outer layer of skin, think of like an onion. Okay, and I'm peeling away one layer of the onion at a time. Um, so the rock in this case is like the onion. Okay, and then we have our picture of abrasion, which I had mentioned before. So in a stream, as the water's flowing, depending on how fast it flows, that determines how big a piece of rock is that it can carry. So your rock is moving along and it's bouncing and bouncing and bouncing and bouncing. And every time that rock bounces on the bottom, it chips off a little piece and it starts to smooth out. Okay, so that little chip is the abrasion. All right, and then ultimately, the rocks will become round and smooth. So if you've been to the beach on the North Shore, you've seen this before, because the North Shore beaches are all rocky, and those rocks tend to be round and smooth. Okay, if you've been kayaking or rafting in a river upstate, Pennsylvania, New Jersey, places like that, you'll notice that the rocks there are also very smooth. If you've had to get out of the kayak or tube, you've noticed that, because you've probably fallen when you step on those rocks. Because they're smooth, they tend to be very slippery. All right, so abrasion happening in your streams. All right, then we get animals. Well, so as you have animals that burrow, so think gophers, things like that, they're pushing into the ground. All right, and what are they doing to the ground around it? All right, so as they burrow in, they're pushing outwards. Okay, and then things are able to flex and collapse, which is just like every other part of weathering we've been talking about. All right, so that's going to do it for today. Tomorrow we will get into the chemical weathering. And again, any questions, guys, please send it to me over in Remind or send it in Classroom. All right, you will have another assignment in addition to this video being posted on Monday with the packet that you guys did. So you did this packet already, the first one. We're going to do the second one, which is on chemical weathering. And again, I'm going to attach a Google form So instead of you filling out these pages here, okay, you're going to have that an answer sheet that you're going to fill out. So you can fill it out for your own notes. And a number of you sent me questions saying that you capitalized something or whatever and it marked it wrong. That's fine. I will be going through and checking it. If the way you type it in doesn't exactly match the way I typed it in, it marks it wrong. But again, I still go through and I'm going to check everything. All right. So be safe, and I will talk to you guys soon. Thanks.